Hello and welcome. In this video I will show and explain the important things to consider when trying to build a bicycle using an old or a vintage bicycle frame, or even when you want to take the whole old bicycle and perhaps restore it or keep it riding and then replace parts as they wear out. So I will put as usually a table of contents in this video's description, and I will also that will also be visible in the timeline, so you can skip to the parts of interest, because it will probably be, like most of my videos, long and in detail, and you will as always have to put up with the background noises and my less than perfect English and my pauses while I think how what I want to say is pronounced in English. Okay, so let us begin. First thing is, why would you want to use an old frame with modern components? Well, I have some ideas and why I use it. Now, especially in this year when I'm recording this, and even in the year before, there was a very huge demand for bicycles, and the supply could not satisfy that, so there was a sort of a shortage of bicycles and bicycle parts. So that is one reason why you might want to find some second-hand or some old bicycle that you hadn't ridden in years and try to get it to work. And why do I think it's good to use more modern components, not the high-end, super special, super complicated, but something that can be easily sourced and found, because that makes maintenance a lot simpler, easier and cheaper. Another important advantage, in my opinion at least, is that when you are using relatively simple components that are readily available, you are less dependent on bicycle shops. So, as it is the situation now in my city at least, you don't have to wait for at least 2 weeks until your bicycle gets fixed in a shop. So you can ride it every day, whether you're using it for just fun or sport, recreation, or as a means of transport. So you are less dependent on the others, and you can more easily, without investing too much money into tools and too much time into maintenance, keep your bicycle running on your own. I think that's a very good idea. So there are several things that can be deal breakers with vintage frames, and here I have one that is from 1973 or 74. It's in good condition. The most important thing, of course, is that the frame has no cracks. You should inspect all the welds, all the parts where the tubes are connected. That's where cracks usually appear. So make sure that it is cleaner than this one now, and make sure to inspect everything. And forks, they usually start cracking on the rear side here, so that should also be checked. And you can also check if it is aligned, but we'll get to that a bit later. The first thing that I pay attention to when I'm looking at an old frame or a bicycle to restore or to take it for use is this part. It's called the bottom bracket shell of the frame. Many vintage frames have Italian bottom brackets. They are far from perfect. One of the problems with Italian bottom brackets is that the right-hand side cup is also screwed in clockwise, which makes them very likely to become unscrewed when you're pedaling from the from the friction that the bearing bolts create in the opposite direction. Won't be explaining that in details now to save some time, but they have this problem, so you need to tighten them really quickly, really strongly with a lot of torque, and perhaps use some thread locker just in case. So they are far from a good engineering solution, but you can still source cartridge bottom brackets both for Shimano Holotech 2 modern standard, that's like this one, and for the square taper. I will also put a link in this video's description to my article explaining bottom bracket standards, threaded bottom bracket standards. So if it has Italian bottom bracket, you will be able to find spare parts, just it's a bit more of a hassle, but it's manageable. If you have the British standard that has left-hand sided thread on the right-hand side cup, then that's ace. That's perfect. That's as good as it gets. It's very practical. It's easy to find spare parts and cartridges, whether you want Holotech 2 or the older Quill, or the older, not Quill, but square taper. This particular frame has an older French style that has practically the same diameter and thread pitch, but not exactly the same, unfortunately, as the British standard, but it is, or English, but it has right-hand side thread on the right-hand side of the frame. So you have the same problem as you do with Italian, but an extra problem of it's impossible to find new cartridge bottom brackets threaded in that way with smaller threading than the Italian, but to have right-hand side on both sides. It can be improvised, but in my opinion it's not worth, unless you're sentimental about your frame and for whatever reason, but it's not worth the hassle. I would avoid such a frame. There are workarounds with everything. You can make anything work. It's just a matter of how much knowledge, tools, time you need to invest, how much money, and for some general home mechanic use, even for most shops, it's not really worth it. I think unless you have some sentimental value that's not measured in money, you should just keep looking for another frame. There are lots of cheap bicycles and frames that are vintage. And how will you know which bottom bracket standard you have? Well, it's best to measure. I will make a separate video on how to remove the cranks and put out the bottom bracket, but you need to put it out and measure it. You can either measure the cups, you're measuring their outer diameter, or measure the bottom bracket shell, measuring its inner diameter. If you come up with less than 35 millimeters, then it is not Italian. If it is over 35 millimeters, you are most certainly dealing with an Italian bottom bracket, which is not too bad, but not perfect. While the below 35 millimeters, it is most likely British, but it's not guaranteed. For example, this frame has the French bottom bracket standard with the pitch slightly different compared to the British bottom bracket standard, and with the right-hand side cup screwing in clockwise also, if memory serves me correctly. So once you measure below 34 millimeters, just to be sure, double check if there's any markings on the cups or on the frame, or Google the frame model to see which bottom bracket standard it has. If you find no data, okay, you can start unscrewing the right-hand sided cup clockwise. If it doesn't move, well, you can check, or you can try all the way, and then you might ruin the cup or the frame. But if it's not a British standard, who cares? You will always be looking anyway for another frame, just to make sure to not damage the tool if you are really unlucky. And there are also some frames that have old press fit bottom bracket standard that have cups that are pressed into the frame, and those are usually of a bit greater diameter, so you can fix those frames if you have the tools and the knowledge by cutting this part out of a donor frame that is racked in some other place and hence useless, or you can machine the insert, or you can cut this out of a frame, then machine it to fit and put it in a freezer to shrink a bit, lower diameter, and knock it in. And then as it heats up, it will stay in place without need of any kind of glue or welding or anything. It often stays and works okay just like that. But that takes a lot of time and a lot of tools. I don't have those tools in my shop, for example. So it's a bit of a, for me it's a no-go if I see a frame like that. But that is, I hope I've explained the first problem that can be a deal breaker when you're considering a frame. So make sure you have Italian or British bottom bracket standard. Next up, we have the forks. Now, old and vintage frame usually have forks that have 1 inch steerer tube diameter and they are threaded. What I mean by threaded is that they are held in place by this bolt, and it is locked in place by another lock nut on top of it. Here it is not present, but I could put one. We have this like a lock nut that is screwed on top, and it presses against this nut, and that's what holds it in place. Now the first problem with this is that setting the bearing preload so that you don't have any play, that it's tight enough, but so that it is not over tightened, is very difficult and requires several trial and error attempts, and is far from practical, because you need to hold this with one wrench and then tighten this with the other, and as you're doing that, this will unscrew a bit, this lower part, so you might get it a bit loose, or if you over tighten it to start with and then try it, then it might still end up being too tight so it doesn't move freely, and so it's a bit of a hassle. It's manageable, but it's not very enjoyable. If you can find a threadless 1 inch steer thickness fork, you should definitely try to use that. 1 inch threadless or ahead bearings are still available, so that can be fixed. But there is another, in my opinion, more important thing to consider here, and that is the quill stem. Most threaded forks use a quill stem, and quill stem has a problem that it is held on by just this one bolt that pulls on a quill, making the diameter effectively wider, and that's what locks it in place inside the steerer tube. So this is how it works, and as you tighten it, it gets locked in place, held by this part. The rest is, you see how much it moves. It's free. Even when you tighten it, the top part is basically free. And I consider this to be an inherently unsafe mechanism, because this bolt can break off without any prior warning. I've had it happen, and I've seen bicycles in my shop that have had that kind of accident. Whenever I say this, there's at least that one guy who says, but I've ridden a bicycle for years without any problems, and thousands of people are riding the bikes with that system without any problems. And that is perfectly true, but it is also perfectly true that it does break off without any prior warning. So it's up to you to make a decision whether you want to risk that or whether that risk is unacceptable for you. Is there a solution? Well, even with threaded forks, if they are made of steel and their steer column is made of steel, you can work around that by finding a fork that has a longer. Here this protrudes just by 1 centimeter roughly, but you can find a fork that is longer, and you will find, for that you will need a lock nut that hasn't got a cap like this, or you can remove this, but that can screw in past that part to lock the fork in place. And once you've done that, you can use a modern threadless stem that is held on by 2 pinch bolts. You put it over the fork, it should protrude, and then you pinch it. Because the probability of both of the bolts snapping at exactly the same time are very, very, very low, and I consider these systems to be a lot safer, especially if they have 4 bolts holding the bars. So if either of these breaks, you will still have control of your bicycle to stop and fix it. The problem with this workaround is that the threaded fork, by having the threads cut into it, is already weakened a little bit by having these threads compared to the standard threadless forks. That's why I would not attempt this with anything but steel steerer tube and steel forks. And I had good success with using steel forks with this, especially combined with aluminium stems, because steel stems will be a bit too hard, and the carbon fiber stems will be damaged while tightened over the threads, but with this it works okay. The problem you might see is having a bit more difficulty in finding threadless stems that have 1 inch this part to hold on to the narrower 1 inch steer tubes, because steer columns, because most modern threadless steer columns are 1 1/8 of an inch or 28.6 millimeters, and these are 25.4. But this can be googled and found, so that's one solution that is on a budget. Finding a threadless fork with this diameter of the steer column is quite difficult. There are only some carbon fiber ones available that I could find, and I will put a link to my article explaining bicycle materials for more details, but carbon fiber has its pros and cons, and it would definitely not be on my budget bicycle project. To leave it at that. Now, the next, while we're here, thing to consider are the shifters. Many of these bicycles have down tube shifters that are usually friction. By that I mean they have no clicks. They just move back and forth, and you push it or pull it until the gear is changed, and same goes for shifting in the other direction. So you need a bit more concentration while shifting gears, but the upside is they are super durable and they work with any kind of cassette derailleur. They're practically universal and hassle-free, and even if you have imperfect housing and cables, they will still work even if something gets frozen or something like that. Another problem is that many people don't like having to put their hands down away from the bars in order to shift, and to circumvent that problem, you can replace these by putting housing stops instead of the down tube shifters. I will put a link in this video description for what that product looks like. Anyway, it can be mounted here instead of this, so that housing can move to that part, and then the cables will go on from here. And then you can put on your bars with whichever shifters you like. You can put friction bar end shifters that go in here, or modern shifters either for flat bars or for drop bars, whatever you like. So that's a problem that can be solved more or less easily. Now to see the back side of the bike, this, I will move it around a bit. All right. This can be a bit of a problem. Modern hubs that you can easily find are 130 millimeters wide or 135 for mountain bikes, but these old bicycles usually have 126 or narrower. Let's measure this one. Let's see where we're at. What does it say? Here it says almost 125. Okay, maybe I didn't measure it quite correctly, but it's probably designed for 126 millimeters wide rear hub. And can you spread this to put in 130 millimeter hub? Technically, you probably could put it in right away, just spreading it a bit, but if the dropout width is off by more than 2.5 millimeters from the hub width, then either if they're wider or narrower, the frame tubes will be in constant tension as you ride, and you will get some fatigue cracks relatively quickly. You can damage your frame. Up to 2.5 millimeters, it's okay. No problems with that. But the good thing is that with steel frames, you can widen this. You can make it narrow. I will show how. With aluminum and carbon fiber frames, that's something that could damage the frame permanently, even if the damage is not visible. Once you do it, further down the road, relatively quickly, there will be cracks. But with steel frames, it can be done. I will now show some tools and explain how that is done, so you can have the frame to use with any hub that you can easily buy. You don't have to source vintage hubs that are of a certain diameter, or to try to hack the modern hubs to become narrower between the dropouts. There is a way to do it, but it weakens the wheel by making the angle of the spokes even less good. I won't get into those details now. Video is already too long, but I will show how this is done. Here I will first use some rope, and I will try to get it along the rear side of the frame. If this frame didn't have these nice convenient holes, I will probably put it here or try to turn it around, tie it somewhere like here, but in this case it's perfect. So I'm threading it through and taking it all the way to the front around the head tube. And I will keep it tight. Okay, I've tightened it, and now I will use this to see if the frame is centered or whether the rear side is whacked, either one of these being closer or further out relative to the frame's center line. And I do that by measuring the distance between the rope and this side and the other side. You can use a simple ruler for that and just measure one side and then the other. It's safer to measure it like this, so you don't put it in the wrong place and get the wrong measurement. This is what I mean. Okay. If this is off center, that means you need to, if you're going wider, you will widen the one that is closer, the side that is closer than it needs to be. And for that you will use a lever like a wooden plank. And let's say this one is closer to the frame than the other one. In that case I would put this inside here and lean it against the tube, and I've put some cloth to prevent the frame from being stretched, and I will hold on against the head tube and push with great force here. And you might need a longer lever depending on how strong you are, but this is the basic principle. So you need to stretch just one side until you get it centered. Once you get it centered, you can use a simpler method for widening or narrowing them down. I will show that in just a minute. Just to show now, if you want to go the opposite direction, if the frame is too wide and you want to narrow it down, then you will start by pushing in the side that is further out than the other side. So in that case we are going around the opposite side like this, and in this case I will be pulling or pushing from the other side. It's the same. Now once this is centered, you can use a tool like this. You need a 10mm threaded rod. It's better to be of very hard steel, of greater hardness. And then what you need to do is you put it, these are 3 nuts that are locked against each other very tightly so that I can hold it by holding it on this side. And then okay, now you can hold one end with 17mm wrench, and you can start tightening this bolt to push this wider. And if you're going for 130mm, you will need to push it to 155 roughly, or even more, because the frame will flex back once you release the tension. You can even see it in the video now. As I start unscrewing this, it will flex back. So what I do is I stretch it out. Like if I'm aiming for 130, I will start with 145, then unscrew it and measure. If I'm still not there, then I would go by 5 millimeters further to 150, then unscrew it and measure, and always going a bit 5 millimeters more until I get it right. Once you've done that, you need to straighten the dropouts, because as you spread them, they will be at an angle. And they need to be parallel with the frame center line to hold the hub nicely in place, not to be skewed. So this is a very simple tool for doing that. I'll just put it on the frame, tighten it. And you need two like this. You can use the tool we've already used. Just need to put this all the way here. And then if it's a bit like this, if they are off, they will be showing something like this. You need to use the lever to put both sides to be parallel. This is what you're going for. After you've done that, after you've straightened them, you will probably have, that will probably make the dropouts to become around 1 to 2 millimeters closer than they have been, depending on where you have measured them, at which section as you were widening the frame. So you might need to make another iteration of further widening the frame. And again, if you are within 2.5 millimeters of the hub's width, then it's okay. And if you make the frame be exactly 132.5 millimeters, you'll be able to use both 130 millimeter road rear hubs and 135 millimeter wide mountain bike rear hubs, so that makes your frame be like super universal. And those are some challenges when you are considering reusing an old or vintage frame or a whole bicycle. They're a super cheap base to build a bicycle on, and today there's a bit of a shortage of bicycles and the prices have gone a bit up, at least in my city, especially for the second-hand bicycles. And this is one solution to consider. Other problems you might face are tire clearance, and if you're using a road bicycle frame and you want to make it a commuter with mudguards, so you'd have to put some wheel inside with a tire and see how much space you have. And those problems can be solved with using some road bicycle mudguards. There are some models made by SKS, so you can usually find a solution, but these would be, especially the bottom brackets, deal breakers. So that's the most important thing to consider. The rest is usually more or less easily manageable with readily available parts from shops that often aren't too expensive. And that's it. I hope I've explained everything nicely. I've also written an article explaining this, but wanted to show what it looks like in real life. And that's it. Thanks for watching and cheers.